Hi, this is Aaron Holmberg at Corvallis Middle School, and this video is about teaching students how to find volume of L-shaped blocks, or we might call them rectilinear prisms. But anyway, they're these kind of images, and they're a pretty challenging task for fifth graders to be able to do. And so this video is just teaching how you might, as a parent, really emphasize the work. First of all, you need to understand that this concept is pretty complex. It involves algebraic thought because sometimes students have to find unlabeled side lengths using algebraic associations. It's also difficult because some students have a difficulty seeing things in 3 dimensions. The final thing that's difficult about it is that you might be somebody who says, I see that this volume, I could make 2 blocks out of it, kind of this brownish colored one and the white colored one. But then you might also have somebody who says, well, I can see that it's like a tall tower with something next to it. And if they go about solving it, even if they use the same strategies, if a student's trying to learn it, they could be confused because they're seeing 2 different ways at once, and they don't yet know how maybe they would go about solving it. So I'm going to show what I try to emphasize to students. The first thing is I want you to look at this model. What I try to tell students is that if you're going to solve something like this, you need to begin by finding these two volumes you could break this into. In this case, I made it into 2 horizontal ones. I could have just as easily drawn a line and cut this into a tall one and one next to it, but I just did it this way this time. The first thing I start with is I said find a corner that sticks out at you, and like you could poke your finger with it. If you were looking at this diagram like this, you have several choices of places where you could poke your finger. This back side, when I say poke your finger, by the way, I mean that there are 3 dimensions coming to that point. It's a sharp point with 3 dimensions on it. In this view, you can see 1, 2, 3 edges coming into that. So you could poke your finger in this corner. You could, of course, poke it on the front. And that one is pretty obvious. You can see all 3. This one right here is also right in the foreground. It's easy to reach. This one on the back side is you can see because it has 3. But this one on the top only has 2, and so that's why that one doesn't work real well, nor would this one down here in this bottom work very well because it has only 2 corners you can see. So what's going to happen in this is that I'm showing students how to work like this in class. If you have a diagram like this, I say first of all find these corners that you can put a dot on, and after you do that, then you're kind of deciding, well, what am I going to cut this into? And if I cut it like I did this model here, it means I would go down, across, and across, and I'm finding length, width, and height. But in this case, I've chosen to split this one off the bottom, so I'm going to go all the way across. And that's going to help train the student's eye that they need to find this whole side length. And in this case, that's pretty easy. It's 12, and a parallel side would be also 12. 3 is labeled, and 2 is on the bottom, so 2 is parallel. It's up there. So those 3 are found. And then the next thing is you would go to the other dot and draw 3 off of it. And this is where you say, well, okay, this whole side length over here is 10, so that's got to be a part of it, and do I know what these other ones are? But really focus first on just teaching students to see this. Again, if they come over to like this, I'll show this one if I were drawing on it, talking about the points. What I would do with an image like this, if I was going to divide this one this way, into 2 shapes vertically, I would literally, even if you have some Legos at home or you can find some somewhere, it's not a bad idea to do this for them. It helps it be real visual. Put a dot on that front corner, and that's going to be corresponding to this spot right here that I've just made. And then find this one here and say, well, I'm going to put it on this front pokey corner right here, so I'm going to make that corner black. And when you do that, then you're emphasizing there's the corner where the three dimensions, length, width, and height, of the volume meet. And then take a pen and just trace off of that side so you can see 1, 2, 3 dimensions, length, width, and height. It also does not matter what direction those dimensions are in, whether you call this length or width or height. You're still taking 3 numbers and multiplying them to make volume. So while you can have arguments about which is length and which is height and which is width, it doesn't matter. The commutative property of multiplication means that no matter the order of those numbers, they're still going to multiply to the same product. And so I take my final block here and I do the same thing. Just make these length, width, height lines off of the corner, and I can see what I'm going to multiply. So when I go again back to my real drawing, and if you have students have a couple little models like this, a lot of these different things they may see on a sheet like this are just versions of these. And if they make a couple just so they can handle, it really helps them think about the the parallel width of the similar width of all these parallel sides to one another, and that can be really useful. So again, if your student's struggling with this, maybe just take time to take the entire worksheet and just do this to it before you even do any math, any work with numbers. It really helps it be visual for students. Once they get the idea of how they're going to work this is a tougher one a little bit because you're kind of looking at the bottom, but obviously that works, right? And you come this way and you have to decide, okay, how am I going to take that? Well, a lot of times we see there's this little chunk, so you might come out and say, well, I'm going to stop right there, and then I'm going to go this direction, and my other point is there because there's 3 and 3. So the reason why you have to pick those two, of course, is that only has 2 dimensions uniting at the corner, and 2 dimensions there, and 2 dimensions. So these are your only 3, and you could use this back one if you wanted, but it kind of usually jumps out at students, that front one more. And then you might do something like this where you make the students trace this length right here. Trace it, trace it, trace it, trace it, and extend it. Sometimes students will do things like they'll go to the corner, and you can say, would you go to the corner on this? Would you trace this line and then go across to this corner? And they'd say no. So you show them that you don't here. And you can also reinforce the idea of parallel lines, that this is going to come down like that. So again, that's a strategy I would probably have students do on a worksheet all the way through like this. It's just identifying a corner and breaking it into 2 volumes where you can see you've got 3 dimensions uniting at a corner that's kind of in the foreground of the shape. Sometimes it might be kind of underneath like this one, but that's okay. You can do it off opposite corners like that. In this